everyone, it's me again, back to maths lesson with audience online. I hope you guys are doing well in boarding house or at home, resting, taking care of yourself. And yeah, we have to go on with the maths lesson as with all the doctors and nurses. They're doing their best for the coronavirus patient, and we must also try our best to learn as much as we can. You're going to be someone productive in the future to also help the community. Okay, so let's continue with the trigonometric. Today we'll learn something on the sine function. Feels a bit weird, there's no audience in the class, but if you guys have any questions, just drop by the WhatsApp group, alright? So I'll try to answer your questions at the WhatsApp group. Okay, so let's continue. Today we'll learn about something called the trigonometric function, which is a very important function. We'll learn how to get the important properties of every single variable over here, the A, B, C, D. But before going to this part, let's learn to sketch a very basic trigonometric function of sine, cosine, and tangent. Alright, so let's start with that. So you have, let's say, the first graph we'll be sketching is y equals to sine x. And the domain of x is between 0 and 2 pi. Alright, again 0 is 0 degrees, 2 pi in degrees is 360 degrees. So in order to sketch this graph, first you need to get interval of 90 degrees, which is interval of pi over 2. So we have 0, pi over 2, pi, 3 over 2 pi, and 2 pi. Alright? Then next thing what you need to do is you have to sine that particular angle. So sine 0, as you know the table, the important table, from 0 to 2 pi. I've asked you guys to memorize it. What's the sine, cosine, tangent for the output, for the increment angle of 30 degrees, 45 degrees, 60 degrees. So that's really important. And what is sine of 0? Sine of 0 is 0. What is sine of pi over 2? So sine pi over 2 is 1. Alright, so it's 1. Okay. What is sine pi? Sine pi is sine 180 degrees. And sine 3 over 2 pi is negative 1. And sine 2 pi is a 0. So therefore, if I were to sketch the graph, it looks like this. Beautiful graph. Okay? So that's between 0 and 2 pi. But in the IB syllabus, it's also important for you to learn to sketch for different domain. So if I change the domain to x between pi and minus pi. Okay? So similarly, how the graph looks like. So now let's sketch it. Y, x, 0, pi over 2, pi, minus pi over 2, and minus pi. Okay? So let's continue with this as well. The same graph, sine x. So y equals to sine 0, again is 0. Sine pi over 2, it's a 1. Sine pi is 0. So what is sine negative pi over 2? So that's the same as sine negative 270, sine 270 or sine negative 90. So that's a minus 1. Okay? And then sine minus pi is the same as sine 180 degrees. So that's also the same as 0. So the graph will look like this. Okay. So actually this graph, you could also sketch it from here. It's a continuation from 0 all the way to minus pi. So if I were to go on, you can see that this part, this section over here, is a continuum from this part. Okay, so it's very easy to sketch this domain if you have this domain, or vice versa. If you have this domain here, you want to continue all the way to 2 pi, it's also possible. Let's continue with the cycle. Alright, easy. So that's a graph of y equals to sine x. So now we'll try to continue with a few more graphs of cosine x and tangent x. So again, x is between 2 pi and 0. For the second graph is y equals to cosine x. So the graph will look like, again, sorry, we get interval of pi over 2. So pi over 2, pi, 3 over 2 pi, and 2 pi. So cosine of 0, as we know, is 1. Cosine of pi over 2 is 0, cosine of pi is a minus 1, cosine of 3 over 2 pi is 0, cosine of 2 pi is a 1. So if I were to continue and to sketch it, the graph will actually look like this. Yes, it's a very nice curve. But make sure that the curve is in this particular pattern, not in this pattern. Okay, sometimes students just sketch it down with their lead. Don't do that. It should be a nice curve that way. Okay, so forget. Don't draw it down straight that way. So curve it down. That'll be a nice, beautiful cosine graph. Okay, so again, if you have any question, please drop it in the WhatsApp group chat. And that is a cosine graph. Alright, we can do the same thing again for between minus pi and pi. So I'll let you do this for assignment, okay? So for assignment, please sketch the graph between minus pi and pi, okay? So between minus pi and pi. So please learn to sketch that graph. Right, let's give you one more example, okay? So for cosine graph, so cosine, again, cosine 0 is a 1, cosine pi over 2 is a 0, cosine minus pi, so cosine pi is minus 1, cosine minus pi over 2 is a 0, cosine minus pi is a minus 1. So the graph will look like this. Or you can say this section is a continuation from here all the way to minus pi. Okay? Easy peasy. Alright, so that's a graph of cosine x. Okay. So again, let's continue with the next one. The third graph will be a tangent graph. Okay, so for tangent graph. So y equals to tangent x. Okay, so for tangent x, it's good to have a different interval. Alright, so I'm going to use interval of 45 degrees. Alright, for you to see it clearly. So 0, after that going to be pi over 4, then we're going to be pi over 2, then you have to continue, alright? So all the way, after pi over 2, so pi over 2 plus, this is pi over 4, this is plus, so it's 2 pi over 4, 2 pi over 4 plus another pi over 4, so 2 pi over 4 plus pi over 4, going to be 3 pi over 4, 3 pi over 4 plus another pi over 4, so 4 pi over 4, so going to be pi, so plus another pi over 4 going to be 5 pi over 4, plus another pi over 4 will be 6 pi over 4, plus another pi over 4 going to be 8 pi over 4, it will be a 2 pi. Okay, so with this, then we have to know that there are 2 points on the x-axis where you're going to get infinity for tangent, and we know that it is actually at 90 degrees and 270 degrees. So you're going to get asymptote at 90 degrees and 270 degrees. So pi over 2 will get one asymptote here. And at 270 degrees is 3 over 2 pi. So 3 over 2 pi, it's going to have, let's see. Oh, I must have missed out something, I'm sorry. I add up too fast. Okay. So pi 5 pi over 4 plus another 6 pi over 4 plus another pi over 4 will be 7 pi over 4. Sorry, I missed out that part. 7 pi over 4. After that, plus another pi over 4, 8 pi over 4. That is 2 pi. Okay? So pi over 2, that's one asymptote. Another asymptote going to be at 270 degrees, that's 3 over 2 pi. So this is 3 over 2 pi over here. That's 3 over 2 pi. Okay? And now we can sketch a graph. Tangent 0 is a 0. Tangent pi over 4 is the same as tangent 45 degrees, it's a 1. It's a 1 here. Okay? And tangent pi over 2, we know it's positive infinity, so somewhere around here. And tangent 3 over 4 pi is negative 1. So it's positive infinity, so somewhere around here. And tangent 3 over 4 pi is negative 1. So negative 1 here. Tangent pi is 0. And we know that tangent 5 pi over 4 is going to positive infinity. And from the right side to pi over 2 is actually towards negative infinity. And then tangent 7 pi over 4, it's going to be a, you have over here minus 1, and then 2 pi is going to be a 0. Okay? So how the graph will look like, it's going to be something like this. All the way to infinity, comes from negative infinity, and then goes back to infinity here. Sorry, I missed out the 1 here. This should be a 1, a 5 pi over 4. Should be a 1 over there, guys. So sorry, the curve should be more like this. Let me draw it up. So 5 pi over 4 is going to be a 1. So curve it and then all the way. So it doesn't look so smooth. It should be very smooth. Okay, that's more like it. So curve all the way to infinity. And comes back from infinity to minus 1 and then to 0. So that's how the graph looks like for tangent x. Okay, so just take interval of 45 degrees, get the coordinates, okay, here, 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 and then look at the asymptote. If you go to pi over 2, from the left, it will approach infinity. If you go to pi over 2 from the right, it will approach negative infinity. If you go to 3 over 2 pi from the left, you approach infinity. If you go to 3 over 2 pi from the right, it can come from negative infinity in order to 0. Okay, good. So try sketching now this graph, but the domain changes to pi and minus pi. So that will be for your assignment. So please finish that part for your assignment. So any question up to here, please put it in the WhatsApp comment. Alright, okay, so now I'll continue with another graphs which is related now to this section. How do you determine A, B, C and D? Since you have done transformation for quadratic function, I'm quite sure that this part is going to be very easy for you. Alright, so let's first come to A. Alright, okay. Raise this section up. Okay. So some students may be asking, why are you using just radian instead of degrees? We don't use so much of degrees because radian is more easy for us to sketch it. So instead of 360, you can just write 2 pi. And a lot of derivation of maths and physics uses radian instead of degrees. So please get used to radian instead of degrees. Okay, so the next graph we will learn is we want to sketch the fourth graph. Let's say y is equals to 3 sine x. Okay, y equals to 3 sine x. So how will the graph looks like? Alright, or I can also write it as fx. Fx is equals to 3 sine x. Okay, fx equals to 3 sine x. It's the same thing, alright? The y-axis could be y, I'll get fx. The domain is the same, so domain again is between 2 pi and a 0. So what you do now is, we know that the graph of sine x looks like this. So that's the graph of sine x, correct? So it's good to label the x as well, 0, pi, and here's 2 pi. Here is pi over 2, and here is 3 over 2 pi, and this is 1. Now this number 3 affects the amplitude. So instead of having a maximum at 1, it affects amplitude. So now instead of 1, you're going to be at a 3 here. 3 here. Instead, at negative 1, you're going to be at negative 3 here. Okay? So now the graph will look more like this instead. So you can see that the graph is similar in shape, but the amplitude gets bigger. So amplitude instead of a 3, now the amplitude is set. So amplitude instead of a 1, now going to be at a 3. Okay, is that clear? Alright. So you can again try sketching another graph as an example. Okay, so let's sketch another graph. Y equals to 7 cosine x. So y equals 7 cosine x. Y and x. Okay, so the graph will look, the cosine graph looks like this. The 1 and a minus 1. Okay, so at the 2 pi and pi. If it goes to 7 cosine x, so amplitude changes instead of 1 to 7. So now amplitude over here is 7. Then 0 is still the same, and then here going to be an example minus 7. Yeah, and here going to be a 7, and 0 remains the same. So if I were to continue with the graph, and so there you have it. That's a graph of the cosine. Y equals to 7 cosine x. So it's very easy. Am I right? Okay. And so for your homework now, what I want you to do is, I want you to sketch a graph of number 3. Sorry, it should be a graph of number 5 now. So now sketch for number 6. Y equals to, let's say, 8 tangent x. Domain is still the same, 0 to 2 pi. And number 7, let's say y equals to 4 sine x. Domain now changes to x 2 pi and minus pi. Alright, so let me reset the camera for a while.